Welcome back again to part 7. We are now over 100 hours into this playthrough, having gone from literally bashing rocks together in the forest, to using an electric blast furnace to process complex steel alloys into various tools. From burning logs in the ground, to 9 electric machines and 5 steam machines for bending, compressing, crushing, magnetizing, and assembling many different materials into motors, pistons, circuits, and even more machines. The base has developed a lot in this time, with 5 distinct buildings for each stage of progression, the latest of which now housing a large bronze boiler and our electric blast furnace to make the first aluminum. We've done a lot in this playthrough, and at this point we have cleared the Terra Firmacraft part of Terra Firma Greg, and planted ourselves firmly in GregTech progression. So now we can look our eyes towards the fusion reactor, and the long road to get there, starting with medium voltage. Oh, this looks so ugly. I could also just go like this. I mean, it's still definitely quite ugly. Okay, so there's a couple things I need to do for the start of this episode. So what we're doing right now is we're just going to get another input for the electric blast furnace, because it can take 200 millibuckets of oxygen and 1 ingot of iron to make a steel ingot. Just 25 seconds. Really good recipe, honestly. I think it's actually about as good as making wrought iron in the arc furnace. There's the machine hull. Storage really does need to get fixed. This is a critical point. Like, I actually can't do anything with this storage system. That will have to be the next thing, directly after this, just fixing storage. There, ULV input hatch. Okay, so this much will do, I think, 10 steel ingots. So I'll just run that recipe. Oh, there we go. Haven't seen this thing run in about 2 weeks. And that's a steel ingot. So, this thing's useless. We can move on. I don't think we'll touch a piece of pig iron or high carbon steel for a very long time if I just keep this thing going. If I made 16 LV circuits, that would be enough. That would be enough to get me into MV. And I might as well, we're not going to have a better circuit recipe for a very long time. So, 16 circuits is probably the most ambitious recipe with these I've ever done. But now we have a ton of steel. Not to underplay the insane steel cost of this, it is actually going to cost 32 steel just for the plates alone. Then I need resistors. I think I have a few resistors. Yep. Okay, so resistors are done. We're going to go on to vacuum tubes. Vacuum tubes are incredibly cheap as well. And for some reason I still don't have a better bolt recipe, and I'm too lazy to change it. So I'm going to get 8... Oh, 8 steel bolts is literally just 2 steel ingots. You see why I haven't changed it. 8 steel bolts is 2 steel ingots, and that's 16 circuits right there. 16 annealed wire, 8 glass tubes, and 8 bolts. There is our perfect vacuum tube recipe. By the way, I don't think I demonstrated just how good this system is. Because right now we're running all 4 of these machines with no problem. I mean, these are not even outputting enough to make 1 machine run, but because of these batteries, that's not a problem. Okay, we get our cables, vacuum tubes, resistors, and steel plates. And this could very possibly be the last time we even use this system. We're advancing so quickly. Put in the 16 resin-coated circuit boards, and oh, it's getting very cramped in here. Still doesn't get old, though. These 16 circuits will be the first half of this episode. I am planning to make an electrolyzer, and this electrolyzer will allow me to turn water into oxygen and hydrogen, make silicon and aluminum out of clay and other things. I don't think this one can do that yet, but... And then the other machine I want to make is the thermal centrifuge. And this thermal centrifuge allows us to pull gallium out of sphalerite ore. And gallium is used for gallium arsenide, which can be used in our first diodes made in the assembler here. And these diodes are what we need for our first MV circuits. So we have the main MV hull material, aluminum. Now we're just trying to get the circuits. And then with those circuits is our final machine, that we're going to make with all of this, the circuit assembler. But for now, let's just focus on the electrolyzer. So here's what we should have made last episode, but it got way too long. The electrolyzer will allow us to make a proper source of aluminum, because ruby is definitely not sustainable. Oh no. Yeah, we're out of copper. I think I can take on the tetrahedrite mine. I don't think it's actually that bad anymore. I think I've just made it better after last time. Predictable. Yeah, this tetrahedrite mine's not lasting another day. It's impossible to mine through it. I built this system, and past it is just all of my mistakes. Oh. Yeah, there's just holes going higher and higher, and this is to try to prevent that from caving in, but that's clearly not enough, because the game's just pulling from other areas. Look at how much chert has been mixed in here. That's from way up there. My torch could never reach. So I've mined around here for about an hour. It actually took me an hour since I was originally planning to save the mine and dig it from the top, but that has completely failed. And what I've just done is I went to the bottom layer, you can see where those supports were, and I just dug down with the cobblestone roof, so there was absolutely no danger. And I depleted this 1/4 of the vein. You can kind of see how it curves, because it's all spherical. I think there's still about 30% of the vein still waiting to be dug up in these rocks, but I'm not doing that. It's too difficult. I'm just gonna leave. Yeah, the only reason I'd come back here is for the nickel mine, because there is still tons of nickel down there. It's probably going to be my best source for a long time. And the nickel mine is safe. It's as safe as the area I just mined in the copper mine. So that's our new copper supply. Okay, so now I have all of this copper, and I just need to cook up a bit of tin, and I can get to work on my new storage system. And with all of that bronze, 12 bronze crates. Now we have the wall of storage. This is going to keep us organized for a very long time. So with everything organized, I have all of these chests dedicated to 2 ore veins each, except for this one because they're really small ore veins. And then here we have LV and MV. MV doesn't currently have anything, but it will. We have ferrous metals, anything with a significant amount of iron involved. Non-ferrous metals, any metal that doesn't have a significant amount of iron involved. I should move tin alloy. Non-metals, which has things like carbon, sulfur, lithium, redstone, and rubber. Also a row dedicated to glass. We have building, pretty self-explanatory. And then 2 chests dedicated to anything and everything TFC or TFC adjacent. Just anything that would be used for that old TFC era that we're now done with. And then create and things related to it, like these brass nuggets that are used in brass hands. We have a chest dedicated to sand. We have 2 chests dedicated to rocks. We have wood, and then we have living with an asterisk because there's a little bit of things like raw rubber pulp and ashes. And also, these bones are definitely not living, but they were once part of a living organism. You can see why there's an asterisk. So I have all of this organized now, and I'm gonna move on to getting diodes. Okay, so first we're gonna do the arguably harder part, because this is terra firma craft, and we're gonna try to get that arsenic from cobaltite. And then we're gonna use our backpack to try to safely get all of that cobaltite, because it will kill us if given the chance. So what I'm gonna do, because I have a water bucket, is I'm gonna just take that cobaltite like that, and I'm gonna use the water to funnel everything into the same place. Oh, that's bad. I didn't place my bed yet. We need at least 3 to make 1 diode. Oh, and it just naturally funneled them all into there. I like that. I think that's enough cobaltite for me to be happy. Okay, I did it. I did it. I actually did it. And I'm dead. But I have my bed here. And how much dust is this already? It's enough for 2 arsenic at least, but most likely 3. I'd like more. Might as well. That was perfect. I guess another way I could do it is I could fill my inventory, walk up to the cobaltite, and then just shift-click some stuff in. There, nice. Okay, so that's how you deal with toxic waste, or any toxic material in this game. But right now, I can actually get twice as many, so I'll have over 120 diodes from this much. No, actually over 250, because only half of it is arsenic. Okay, then we definitely have enough, and I've gone way overkill. I left my bed in there. It's such a labyrinth to get there. I mean, now we have this mine. That goes all the way down there. And then we have the ladder going through here, over the pile of rubble. And then I have to work my way down the quarry to get my bed. That's already 8 steel. Look at this. Welcome to late LV / early MV. We just have steel stockpiled everywhere. So I do have to process this cobaltite. I don't want to process all of it now, so I'm just going to process the poor cobaltite now. There. That was perfect. Okay, and now the difficult part is that I have to wash it, or centrifuge it. I think I'm going to centrifuge it. There's a little bit of sulfur, which is nice. I want it to appear there so that I can put it in my backpack immediately. It didn't. Okay. I'm fine. It might not actually be hazardous now. They might have been actually nice. No. Okay, I was just fast. I don't have my spawn set here. Yeah, I'm dead. No, I'm not. And then there's just one last step to make arsenic in here. So I explained this quite badly in the recording. Basically, I need to make arsenic, and my electrolyzer was not good enough to directly electrolyze cobaltite, so I would have to put it in the EBF to make arsenic trioxide, and then electrolyze that. But that needs a lot of oxygen. It takes 3 buckets of oxygen per recipe, which is quite crazy, but then when we electrolyze arsenic trioxide, we get that oxygen back. And there, now it is running the cobaltite recipe. It's actually really fast. So this will build up with sulfur dioxide, and now we have cobalt oxide and arsenic trioxide. Everything is oxidized. Okay, so we have 6 arsenic trioxide dust here. I will need to run. There, it's running 1 recipe. This is gonna get us 2 arsenic. I'm at 3 health. Yeah, this 2 arsenic is just gonna stay here until I have gallium. So, to get gallium, we need a thermal centrifuge, and I already made the plates for that. So I'm just gonna make casing. Okay, 4 copper wires, that should be enough. Now we have the thermal centrifuge. I don't know if this far down the line I'm actually able to run the thermal centrifuge. It needs 30 EU a tick, so that will not work. I cannot run it here. There is a free wire right there. 20 crushed sphalerite ore into the thermal centrifuge. I really like the animation on this machine, but it does take a very long time to run its recipe. So, when you actually have the ability to make so many machines, gallium is definitely an easier part of the recipe. What's not easy, though, is this. I need to very quickly craft it together. Why isn't it crafting? It's a mixer recipe. Where's the mixer? Okay, it's in there, and now it's making the gallium arsenide, which is equally toxic. We have 2 gallium arsenide, which we can turn into 8 small piles, which we can turn into 16 diodes, so we don't have to do this often. There, that's gonna get us our 4 gallium arsenide. So then this is twice as much glass as I need. There they are, they go in the chest, and we have our first MV components other than aluminum. This is already enough for a MV circuit, and I can make a phenolic circuit board as soon as this is done, so I'm actually going to get all the materials ready for that. So our diodes are done. I'm gonna put a bucket of glue in there and 20 wood pulp, and I think I have to set a circuit. 1. And that'll just start making phenolic circuit boards. 2 phenolic circuit boards. And 2 phenolic printed circuit boards. Now the big recipe. I'm missing steel. Thank you, game. So that's 1 MV circuit, and that's 2 MV circuits. These are so expensive. So now we have an MV circuit, meaning MV machines are obtainable. But I'm not going to make them immediately since the circuits are really annoying to make. Instead, I will make a circuit assembler which halves the cost of LV circuits and replaces the steel plate with a single ingot of tin, and also slightly lowers the cost of MV circuits. This is the most powerful LV machine, and it's by far the most expensive, with a total of 7 motors and 9 LV circuits, plus the added cost of making MV circuits, and this LV emitter, which needs quartzite made in the autoclave. Okay, I made enough steel plates for the autoclave and the circuit assembler, and that is 1 basic autoclave. And I'm gonna turn that all into quartzite crystals. So resistance actually worked out really well here, because this is using 24 EU a tick, and this is exactly 8 blocks from the generator. So this is gonna use exactly 32 EU, which is 1 amp. I believe to make an LV emitter, I just need to go like this, and there's our emitter. 16 more tin cables, and that was probably the fastest motors ever made in this playthrough. And then LV electric piston, and we're not done. LV robot arm. I think this is everything. We have emitters, we have conveyor belts, we have robot arms. Yeah, I need 2 robot... No, I don't. No, I can make it. Let's go! LV circuit assembler. This thing also needs really high power. And now all the way over here, we're putting our circuit assembler. This is quite possibly the last LV machine. I have just been rapid firing these things out. Just today we got the thermal centrifuge, electrolyzer, autoclave, and the circuit assembler. So there's only one way to show off how good the circuit assembler is, and it's to run it. We put all the different circuit materials in, and it's making it. So with this recipe, I have essentially 1 LV. I have really cheap, easy hulls that are made from steel, that's made in the blast furnace, which uses oxygen from this centrifuge, and then circuits can be made in this circuit assembler practically for free, with all their components made easy in this assembler. LV is done. I can make anything. So now we just need to get that MV turbine. I could do a gas turbine, but right now this boiler is still enough. And I can use aluminum pipes soon. So this is the first real MV thing, though, with the MV motors, MV hull, and MV circuit. Everything's blue now, and it needs aluminum. Oh, and 2X wires. To get a steady source of aluminum, I'm gonna need sapphire. And sapphire is just really gonna be annoying to find. I did find a little bit on a cliff nearby, but that was a tiny amount. And now there is our ore prospector, and I can just charge this in a battery buffer or any machine. Okay, there. We have an ore prospector, and we can see a lot of things. Oh, there is... Where is this? There's lithium right under our base. Yeah, it's right there. Actually, there's about 100 sapphire here. I didn't think the vein would be this sparse. I'm getting no sapphire. I've mined the entire cliff all the way down to the water. That's what it used to be. And I've got this much sapphire. Here we go, 2 more aluminum dust. Now we're actually making aluminum ingots. Here's 2 more. Okay, then our green sapphire, which is a byproduct, is chemically the same as normal sapphire. So I can just use that for more aluminum and oxygen. We already almost have enough aluminum to make our turbine. That is so much aluminum being used right now. I hope I didn't screw up. Okay, so the cost of cables have not changed, but I now need 4 ingots worth of rubber with the copper cables in the assembler. And that is now the only way to make copper cables. There is no other recipe. In the future, these can get better with synthetic rubber, but right now I need an ingot of rubber per. But with those copper cables, I can make our first MV machine hulls. Now these look much cooler than our old LV machine hulls, if we compare the two machines. Now in new versions of GregTech, they completely ruined it. So with all of this aluminum we're now processing, I should actually get everything else for this turbine. So we're now going to make our first MV motors. Okay, here's all of our 2x cupronickel wire. I can melt down all of the rubber sheets for cables, and we're already basically done. Okay, now we put the copper cables there, cupronickel cables there, aluminum and steel, and there are our MV motors. There's 2 new LV circuits, 3 phenolic printed circuit boards, 6 diodes, and 6 copper wire. And we can run our first circuit assembler LV circuit recipe, which uses a little bit less copper and 1 less circuit, which is actually a huge improvement. And with these copper cables, I can make an MV turbine. So now we can place this MV turbine all the way back here, and that is so much power. And since I made 2 other MV circuits, I can use that with some silver I've just cooked up to make all the silver wire I need and make the electrolyzer. There, our first MV machine. Now this is huge, actually. And I'm gonna plug it directly into the turbine for now because I have nothing better to do, but in the future I'm gonna have more copper cables. Every recipe here just got unlocked. Like, everything. And that includes things like using lazurite and lapis to make aluminum, and you saw that massive lapis vein, or maybe you didn't, probably cut that out. Sapphire is a redundant recipe now. Okay, so the focus of the rest of this episode is going to be basic MV infrastructure, just like we did in LV, except now everything's MV. So instead of trying to get steel reliably, I'm going to try to get aluminum reliably. Instead of getting LV circuits reliably, I'm getting MV circuits reliably. And right now I'm focusing on that aluminum. Look at how much power we're using right here. This is 256 EU with both of these machines combined. So after a while of thinking, I have decided that our best source of aluminum is not actually going to be clay, but lapis. Lapis dust itself doesn't make any aluminum, but it makes sodalite and lazurite, which I can also mine in the same vein, and then I can electrolyze those into aluminum. Yeah, and they both have great ratios and great byproducts. Chlorine gas is going to be amazing for things like hydrochloric acid. We do have a lapis vein located at the tetrahedrite mine, but I found a much larger one by the magnetite mine, and that's much closer and also has clay nearby. But yeah, I've known this area has a lot of clay for a while. It was our main source for such a long time. So, lapis I've seen in quartzite, so I assume that's where we'll see it here because this is chert and quartzite is above us, well below us. Oh no, seriously? Well, we found the quartzite, but we have ended up in a cave once again. Okay, so the idea is to keep this basically a quarry, because the roof is so high that I don't think I can activate cave-ins. This area is a bit risky, but right here, it's just too high. Okay, that cave is way closer than I thought. I would not have started digging the way I have if I knew it was that close. This makes things really dangerous, actually. I don't like that at all. This is actually going really well despite that random cave. And I'm not going to go into the walls yet. That will cause so many cave-ins that are actually detrimental. Yeah, this was shockingly successful. I'm gonna get up here now, and we're gonna go home. Hold on, I have to check something. If there's so much magnetite and this cave has so much dirt... Okay, yeah, the magnetite is in here. If I were to ever mine this, I would start pretty high up. But you know what? I will need vanadium quite a lot. Don't I need vanadium steel for the MV cutter? So this is necessary. I'm actually gonna take this then. Okay, so we have a ton of calcite, sodalite, lazurite, and lapis, as well as vanadium magnetite. This vanadium magnetite I will actually just leave in a chest. There, that is a good mining trip. And then we also have all of this quartzite. So this is quite likely the best source of aluminum for a very long time. It's not even that slow. 3 more aluminum dust. Okay, now that we have a stable source of aluminum, let's address some of the other byproducts. So here we have sodium, which can be used in batteries. I probably won't use it in batteries because we can get lithium just as easily, and it's like 3 times better. Then there's aluminum, which I'm already using in this blast furnace. There's chlorine, which we can't use yet, but it will be used in polyvinyl chloride, PVC. And hydrochloric acid is probably one of the most useful because it's just used in everything. I mean, it's an acid. I'm pretty sure it's in your body. But the last byproduct is this silicon. Silicon can be used in the blast furnace to make monocrystalline silicon boules. Basically what that means is that it is a perfect crystal of silicon, or near perfect. And so we can cut that up into wafers, engrave the wafers. So what we want is this integrated logic circuit. So these logic circuits made out of silicon will be used to make integrated circuits. And integrated circuits are really good because this starts at LV. Our current circuits, you have to make a ULV circuit, the vacuum tube, and upgrade it to LV. But this just makes 2 straight LV circuits for pretty cheap, and then it can make 2 MV circuits out of that, which is half the price. So this is really why we're gonna do it. And for that we need integrated circuit chips, which will need an MV cutting machine, and a wafer, which needs an MV laser engraver, and a ruby lens, and a ruby lens needs a lathe. I can use an MV lathe with a ruby plate, but I won't do that because exquisite ruby really isn't that bad to get. For that we're going to need a lot of LV circuits. So I always get a little bit nervous when it starts raining. In case you don't know, rain will just blow up any machine in GregTech. So whenever it rains, if I screwed up somewhere in my roof construction, then I will just lose my machines. Okay, that will be 32 resistors. That is just so cheap. And then I have the resources for all of my vacuum tubes here. But because I have the glue in there, I'm actually going to work on the coated circuit boards. That should be 16... What was that? Was that just lightning? No, it's our turbine! Oh no, I just put it right next to there. We only have 1 LV turbine now. That scared me so bad. That's probably one of the cheaper things we could have lost. The nice thing about having a battery buffer is that even though we're missing a turbine, we are going to be running at full capacity still for a long time, but you can see that the buffer is going down quite quickly. 32 red alloy wire, 32 vacuum tubes, 32 resistors, and 16 resin-printed circuit boards. That's 32 LV circuits. We just did probably the largest circuit recipe again. We will never make this kind of circuit ever again. That is the last time. And no, that does not mean we're not making LV circuits ever again. In fact, I'm pretty sure they're needed for AE2. But what I actually mean is that this specific kind of LV circuit isn't going to be used again. I haven't really explained this yet, but there are 3 kinds, actually sometimes 4 kinds of each tier of circuit. So in LV, we have the basic circuit, which is first made like this, and then in the circuit assembler. And then there's the logic circuits made in the circuit assembler. And then much later, there are microprocessors. which need plastic circuit boards and SOCs. Then MV circuits, we're using this one right now. This recipe kinda sucks, but once we have integrated circuits, it's gonna be twice as good. And then later we can just make straight MV circuits with microprocessors. But yeah, every circuit has a bunch of tiers. I'm sure a voiceover will make some really cool diagram to show it. And that's our basic sifter. Quite possibly the last machine we make. We'll go back for more ruby once we need chromium, but right now that is its only purpose, being turned into a lens. Okay, now we have an LV lathe. Literally just 5 minutes ago I said the sifter would be our last machine. I just made another machine. So now we have our first purified ruby, and we can put it in the sifter, and we have a 5% chance of getting an exquisite ruby, which we can turn into a lens. If I get lucky enough on the first try. No, okay. Oh, we just got 2 exquisite rubies. That is ridiculous. Okay, I will immediately put that in the lathe and hope that it locates some more amps to put in this thing. So now I have the lens required in the laser engraver, but no engraver to put it in. So it's time to make some MV circuits. The last few circuits have used up all of my silver in this recipe, the phenolic printed circuit board, and now I can't make any more silver, so I have to find an actual silver mine to replace the gravel I've been surviving off of this far. Additionally, I decided to use my chlorine to make iron 3 chloride, in a much cheaper phenolic circuit board recipe. But first, time to find that silver mine. So what I'm gonna do is I'm just gonna start prospecting everywhere that I know is rhyolite. Because under rhyolite is granite. There's a native copper mine here, and I think that's sphalerite. Oh, wow! Okay, so that is a huge chalcopyrite mine. And then there's also this sphalerite mine, very large. I'm gonna check out the lead I see over here, but it's likely just another bismuth mine. No, that is actually what we want. That's a huge silver mine. I'm an idiot. Oh, remember near the start, I was going through this area, and I marked off that hematite mine. But right next to the hematite mine was a bunch of silver. And yeah, that's right over here. Okay, so now I've just turned this into a mining area. We got the stairs going up from the water, and then it goes up here to the hematite mine, which I will have to decorate in the future. Now I'm ready to start digging. Okay, we finally reached the actual ore vein. I'm gonna fill up my inventory now because I'm scared of dying to every different kind of ore. I'll go one more layer down, then figure out how to pick this all up. Am I still dying from something? Or is that just regular poison? I think I got everything I wanted in there. Yeah, I did. Yeah, this stack of rich silver alone is enough for our 10 MV circuits. And we're gonna make our first acid, hydrochloric acid. That is a fast recipe. Wait, I can't hold the hydrochloric acid. The great thing about having so much gold is you can do something that humanity basically never did, and it's to use gold for chemical storage. Gold is just impossible to dissolve in acid, so it's a great way to deal with my hydrochloric acid. There, that will very slowly make us our potent acid. I'm pretty sure the iron 3 chloride is also highly acidic. I mean, it's used for engraving circuit boards of every kind, so... This much iron 3 chloride can do 30 phenol circuit boards, so this is actually already enough for our purposes. And now the moment of truth. I put the iron 3 chloride in there, phenolic circuit boards, and silver foil. This is the proper way of making a circuit board in real life. The first circuit boards would really just be a breadboard to stick all your wires on. But this one now actually has things built in. This would be more like the circuit board you might have seen in Veritasium's video on early electronics. So our 10 circuit boards are done, along with our 20 copper wire, 20 LV circuits, probably the most LV circuits we've ever held, turning into 10 MV circuits, the most MV circuits we've ever held. And we did have to do quite a lot for the silver on this, but it was worth it in the end because now we can consistently make MV circuits. And these 10 that I've just made are enough to get the MV mixer, the MV cutting machine, and the MV laser engraver. And all of those things are specifically meant so that we don't have to do this ever again. I actually feel like this project did take a ridiculously long time, because I've been sitting here grinding for all of those materials, the ruby lens and all these machines. I've been sitting here for almost 2.5 hours, but it's so worth it. GregTech is fun, try it out. So next I'm going to batch craft all of the motors required for those machines. So that should be 6 motors, I'll make 8 because we love rounding to the nearest power of 2. Okay, so here's our 16 cables, 16 rods, 8 magnetic steel rods, and all the copper nickel cables to make 8 MV motors. We're already batch crafting MV components, that's great. Okay, so let's start with the mixer, because the mixer is probably the most useful to get first. At this stage in the game, I don't really know many special recipes for it other than vanadium steel, which is what we're doing it for. Vanadium steel needs vanadium, which I mined while we were down at the Lapis mine, and then some chromium, which I got from processing rubies in here. So the only thing missing is the mixer itself, but we have most of those components. All we're missing is those hulls. Ekiba, why did you take, what is this, 27 aluminum ingots? It's because I'm gonna craft everything all at once. All of the machine hulls at the same time. And there's 3 MV machine casing. That is a whole 3 hours worth of aluminum right there. But that was really easy, because I stockpiled everything. I've already made all the hulls for these machines. 3 MV machine hulls. And that's it, MV mixer. And only now I realize that I can't power it. Can turn our turbine like that, get our MV cables like that. I kind of want to see the orange on the inside. There. Now I just have a live wire there that I can kill myself on. Maybe not then. Electrolyzer and mixer. Okay, so I have this mixer now, so the next machine we're getting is the cutting machine. So I need 1 batch of vanadium steel. So what I'm going to do is I'm going to drop this chromium onto the ground and immediately throw it into the mixer. Then I'll also need 7 steel. And then finally, I need vanadium. 20 seconds, we'll have enough vanadium steel. An 80-second recipe. Maybe I won't process all of it. Time to electrolyze 66 sodalite dust, just for fun. I have nothing else to do with my MV machines right now. Yet another first for the MV world, our first MV conveyor module. This thing is really, really good at transferring items, and we don't care because we're using it in a machine. I like that sprite. I don't know what it is about it. It just seems like such a solid ingot. I don't know why I like this one ingot so much. Kinda sad that I have to turn it into plates now. I can grab wire cutters, and I think I can already turn this into a saw blade. Yeah, I can. And this is the right thing, right? Yes. And I believe that's everything. MV cutting machine, or cutter, because we're in the new version. So this thing not only cuts my silicon wafers, it can take a rod like a bronze rod, and it can just cut it up into 4 bolts instead of the recipe I'm using here with 2 bolts. And that makes vacuum tubes even cheaper, as if that's actually necessary. So, while waiting for aluminum to smelt, I just decided to make a distillery because the cutting machine runs faster if it has distilled water. Okay, the aluminum finished smelting, so I can make these MV pistons. And that's one of the last things we need for the laser engraver, except for one thing. This emitter. I ran past everything, going like, okay, this needs 2 MV circuits, cool, it needs a flawless emerald. Cave noises also don't help, because that means it... Oh! I guess I way over-prepared for this. Yeah, thorium isn't very radioactive. It is radioactive, just not that much. Beryllium, however, it's really bad. It's so bad. Nile Red made a video on it. I didn't even realize it was toxic at all until that video, but like, wow. So we're gonna try not to mine that. Anyways, this is way more emeralds than we need. And while having extra emeralds is great for other emitters and sensors, I only really needed 5 ore. Okay, the Flawless Emerald is already here. I didn't need to do anything else. So there's the MV emitter, and there is the MV laser engraver. And I don't have any cables for this. That's just wonderful. So now we can take the ruby lens from earlier, and we can put it into the laser engraver. And right now, this doesn't do anything for us. Ruby lens without any silicon is only for making tiles, basically. But you can see all these circuit recipes, and I need a silicon wafer. This is our cutting machine that comes in. And that will need a silicon boule, 32 silicon dust, and a small pile of gallium arsenide. So we got tons of silicon. So I'm just going to take this 32 dust. There. So this is a really long recipe. 450 seconds to make one monocrystalline silicon boule. So I'm going to have to do other things while I wait for this 450 second recipe to finish. But once it's done, I can cut up everything into wafers. Oh hey, the monocrystalline silicon boule is done. So now I can grab some distilled water from our distillery here. And then we can just cut it, and with distilled water, this is only a 30-second recipe, so that's nice. Also, having this is great for other reasons as well, because in this circuit, we will also need tin bolts. That's not a problem, since I can use the rolling mill to turn it into 4 tin rods, and then go in here to turn that into 16 bolts. That actually takes a surprisingly long time. Okay, so with these silicon wafers, I can now actually engrave my stuff. I'm only gonna engrave one right now, because it's such a long recipe. All of these are long recipes. But this will get us our first integrated logic circuit. And on an actual silicon wafer, this would be engraving like dozens and dozens of circuits, probably even more, onto all one wafer, and then I cut those wafers out to get the actual circuit here, the IC chip. I actually learned a lot of stuff about how computers are made because of GregTech. There, ILC wafer. There, 8 IC chips, and now I'm gonna work on everything else to do with this circuit. So finally I can start putting things into here. The IC chips, the resin printed circuit boards, the diodes, and the resistors that we have too many of. What else am I missing? Oh yeah, copper wire. So in 10 seconds, this can make an ILC. Actually, not an ILC, it's called an integrated circuit. No L in it. I remember they used to be called integrated logic circuits, they've changed the name. And at the same time, we're working on the MV variant, so that means making our circuit boards, phenolic circuit boards. That'll be running alongside all of this, and this, and this, and this, and the extractor. I don't even think we have enough voltage to run this. Battery buffer's being pushed to its limits. There, 16 LV circuits. Not too impressive, we did a 32 circuit recipe earlier today, but what is impressive is that with 16 LV circuits we can make 16 MV, which is why we even do this. Also, these logic circuits have the capability to be upgraded all the way to HV, but that'll be for next episode. Okay, the final input, we have 32 silver bolts. Put it in, and wow, that is a circuit recipe and a half. But this is going to be making 2 MV circuits at a time, so these are outdated. I'll use that last one probably on like a drill or something. But we're in the age of integrated circuits. Look at that. But yeah, just like the old MV circuits, it can make any MV machine, it's just cheaper. So that is it for this episode then. We got all of this emerald and this lead and lapis, but all of that to get tons of aluminum, tons of silver, and produce this massive MV line, which is now producing a bunch of ICs. So, next episode, I guess we will work towards the end of MV. Thanks for watching.